So write down the next topic as relative molecular mass. Relative molecular mass. You all are familiar with the fact that molecules are collections of atoms, and if they are collections of atoms, obviously if you are interested in calculating the total mass of the molecule, so you need to add up the relative atomic masses. Just like suppose you have H2SO4. It is a molecule which comprises of atoms of hydrogen, sulfur and oxygen. So if you are asked that what is the relative molecular mass of H2SO4, so you need to simply count on the relative atomic masses of all of them without missing out any one of them. And last class I have given you the list of atomic masses, and according to it, if you add them up, it comes out to be 98U. So as the relative molecular mass is also expressed in U only, atomic mass unit only, so we can say that a molecule of H2SO4 is 98 times heavier than the same standard of reference, isn't it? 1/12 the mass of carbon 12 isotope atom. Can we write it? Yes or no?
Yes, sir.
Just see. Oh. The molecule is collection of atoms, and if you need to calculate the molecular mass, relative molecular mass of H2SO4 or any other molecule, so you have to first of all take care that what is that molecule made up of, what are the atoms present in it. And after we make out that what are the atoms present in it, we need to add up all the atoms present in it, okay, without missing out any atom, and whatever total comes out will be the relative molecular mass. It is just like saying that if in a room you have different substances present and you need to calculate the mass of the room, so obviously the total mass of the room will be the sum total of masses of all the objects present in that room. So we need to add them up, and after adding up, whatever value comes out, obviously everyone will be expressed in the units of kg only. So here also, as every atom is expressed in terms of U, so overall value will come in terms of U. So whatever value comes out, whatever number comes out, so it will be that many times heavier than 1/12 the mass of carbon 12 isotope atom. So accordingly, we can define the relative molecular mass in a similar way as that of relative atomic mass. What was the definition of relative atomic mass? It was number of times an atom was heavier than 1/12 the mass of carbon 12 isotope atom. So same way we can write it is defined as the number of times a molecule is heavier than 1/12 the mass of carbon 12 isotope atom. Everything is same. The only difference is previously when we were talking about single atoms, so we were writing number of times an atom is heavier, and here it's no longer single atoms, rather it's collection of atoms which have independent existence in nature, and for that matter we are writing number of times a molecule is heavier than 1/12 the mass of carbon 12 isotope atom. As for example, relative molecular mass of H2SO4, we have just now seen how it came out to be 98 U. So it is calculated by adding up all the relative atomic masses of atoms present in a molecule. Just see whether it is clear to everyone or not. If you have got any doubt, you can clear it out. So mathematically, can we write relative molecular mass equal to actual mass of a molecule divided by 1/12 the mass of carbon 12 isotope atom? Same way? Yes or no?
Yes, sir.
Okay. So I hope everyone has written down the definition and whatever I have written on the board, everything is clear.
Yes, sir.
Yes, sir. Yes, sir.
So I have given you the list of atomic masses in the last class, if you can recall, and from that we will be able to calculate the relative molecular masses of some of the common molecules. So molecules are collection of atoms which are capable of existing independently in nature. This is what we have learned. So based on this concept, try out a question. I'm writing down the question on the board. Just see whether you are capable of doing it or not. Calculate the molecular masses of the following. Calculate the molecular masses of the following. Number A, sugar. C12H22O11. Blue vitriol. CuSO4.5H2O. Potassium ferrocyanide. K4 FeCN6. Oxalic acid. glucose. Okay, so try out these ones. I hope you will be able to do it without my help. Do you require help in any of the questions? What will you do for blue vitriol? You have to add up the atomic masses. Now here it is a dot. So what is the significance of dot? You have to simply add it up. 5 molecules of water needs to be added up. Each water is how many? How much is the value of each water molecule?
18.
18. So you have to simply add up the atomic masses with 5 into 18. Okay.
Sir, how
So try
we
them
will
out.
do the oxalic acid?
Oxalic acid, you just count on the total number of carbon atoms. How many carbon atoms do you find out? 2, na?
Yes, sir.
So 2 into 12 plus 4 into 16 plus 2 into 1 plus 2 into 18. Okay.
Okay, sir.
Try them out and tell me the values. Anyone getting the answer for the first one? Sugar?
Sir,
242.
Sir, 342 U.
No, sir, 342.
342 U. 342 U. You must express them in terms of U. That is mandatory. Anyone getting blue vitriol?
249.5 U.
49.5 U.
Very good. 249.5 U. Okay. So first one, according to you, is 342U. Second one, what did you say? 249.5, isn't it?
Yes, sir.
What about third one? Could you calculate it?
Sir, 368U.
Yes. 368U. See, anyone, if you're not getting it, you please tell me, but don't write without calculating yourself. These should be the answers that should come. Anyone getting the answer for oxalic acid as 126U? Just see.
Yes, sir.
Oh. Swastika Nath, getting it?
Sir, yes.
Okay. What about Tuhina?
Yes, sir.
How much done? Could you complete oxalic acid? Tanisha, how many done?
So I'm doing the oxalic acid.
Okay.
Sir,
Yes, beta.
sir, for glucose, I have found 180.162. Sir, you have taken the approximate or what?
So I got 182.
Hydrogen don't. No, hydrogen you should take it to be 1. Don't take 1.008. Hydrogen in every
Sir.
case you take it to be 1.
So I got
Okay,
182.
182 is incorrect answer. How it is 182? 12 into 6.
Sir, not 182. Sir, 180.162.
The boy is saying that he is getting 182.
Oh, okay, sir.
See, where have you gone wrong if you are getting 182? 12 6 are 72. 16 6 are 96. I think it should come out to be 180. Somewhere you have committed some mistake.
Oh, yes, sir. Yes, sir. Yes, sir.
Yeah. How many of you have completed all of them and getting whatever answers have been written on the board properly?
Sir, I have got it.
Okay.
So then,
So as I said, you must do it yourself and must get the answers that I have written on the board. Please don't write the answer directly without doing it. Anyone whose value is not matching with what I have written on the board, please tell me, I'll show you. Could everybody do the potassium ferrocyanide?
yes, sir.
There are 4 potassiums, 1 iron, 6 carbons, and 6 nitrogens, isn't it? Okay, can we proceed further if you have completed all of them?
Yes, sir.
Yes, sir.
Yes, sir.
Those who are not getting, at least write down the answers and later on see whether you are getting them or not. So after discussion of what is relative molecular mass, we'll now talk about what is gram molecular mass. Just as in the previous class, we had discussed the relative atomic mass, and just thereafter, we discussed about the gram atomic mass. Same way, nothing new again. Gram molecular mass or 1 gram molecule. Both are same. Gram molecular mass and 1 gram molecule are same things. Just like gram atomic mass was same as 1 gram atom. When relative molecular mass is expressed in grams, it is called gram molecular mass. This is the first definition. So whatever value you get in terms of relative molecular mass, which is expressed in U, if that U is replaced by gram, then it becomes a gram molecular mass. But there is a difference when talking about the gram molecular mass. When we talk about relative molecular mass, we talk of a single molecule of any substance. But when we are converting that relative molecular mass to gram molecular mass, no longer we are talking about a single molecule, rather we are talking about Avogadro's number of molecules, which is 6.022 into 10 to the power 23. In other words, it is mass of 6.022 into 10 to the power 23 molecules of a substance. So just like when we talk about relative atomic mass, it was a single atom we were talking about, but the moment it is converted to gram atomic mass, no longer it was a single atom, rather it was Avogadro's number of atoms. Likewise, when we are talking about gram molecular mass, no longer we are talking about a single molecule, we are talking about Avogadro's number of molecules. Say for example, relative molecular mass of H2SO4, as I showed you, was 98U. How many molecules of H2SO4 weigh 98U? Tell me.
Sir, 1.
One molecule. So therefore, mass of a single molecule of H2SO4 is equal to 98U. Now, if we replace the U by gram, it becomes gram molecular mass. Gram molecular mass of H2SO4 is equal to 98 grams. How many molecules are hidden in 98 grams of H2SO4?
Sir, 6.022
6.022 into 10 to the power 23.
So mass of 6.022 into 10 to the power 23 molecules. Is it understood the difference between the two?
Yes, sir.
So as I said at the very outset, that gram molecular mass can also be called as 1 gram molecule. So therefore, we can write 1 gram molecule, which is altogether a different entity of H2SO4, weighs 98 grams. So gram molecule altogether is a different unit. 1 gram molecule has how many molecules in it? 6.022 into 10 to the power 23 molecules, isn't it?
Yes, sir.
And 1 gram molecule weighs how much? It weighs equal to its gram molecular mass. Now this number is fixed, no matter whatever be the molecule we are talking about. But this value will be different for different molecules. For H2SO4 it is 98 grams. For others it will be something else. For glucose it will be 180 grams. For sugar it will be 342 grams, so likewise. Okay. Is it clear to everyone?
Yes, sir.
Say for example, 1 gram molecule of sugar in terms of numbers, how many particles are there in 1 gram molecule of sugar?
Sir, 6.022 into 10 to the power 23.
And in terms of mass, how much will be 1 gram molecule of sugar?
Sir,
You have just
342.
now calculated. You have just now calculated it is 342 grams, isn't it? So 1 gram molecule of glucose. Accordingly, in terms of molecules, how many molecules will be there? Is it not same value?
Yes, sir.
But in terms of mass, how much will be the value?
180 gram.
180 gram.
180 grams. So hence we can say that gram molecular mass differs from substance to substance in terms of mass. But as far as the number of particles are concerned, everyone will contain the same number of particles, that is Avogadro's number, or 6.022 into 10 to the power 20. I hope it is clear to all of you.
Yes, sir.
Okay. Completed? Should I proceed further? Anyone has got any doubt? No?
No, sir.
Okay. Write down a question. Calculate. Number A, mass of 2.5 gram atoms of magnesium. Number B, number of gram atoms in 1.4 grams of nitrogen. So we discussed the concept of gram atoms in the previous class, and those who are not present in the previous class, let me tell you, nothing different. So when we are talking about gram atoms, it is same as that of gram molecules. The only difference is when we talk about gram atoms, we are talking about a single type of atom. But when we are talking about gram molecules, it's collection of different types of atoms. But otherwise, the concept remains same. 1 gram atom of magnesium is how many grams? Look at the list and tell me. 1 gram atom,
24.
24
Sir,
grams.
24 grams.
24 grams, isn't it? So the moment I talk about gram atom, it means that we are talking about Avogadro's number of atoms, and it will weigh equal to its gram atomic mass. So if 1 gram atom weighs 24 grams, come to the question. It has been asked about 2.5 gram atoms of magnesium. So 2.5 gram atoms of magnesium will be, of course, 2.5 into 24, isn't it? If cost of 1 chocolate is rupees 20, then cost of 5 chocolates, as you all know, will be 20 into 5. The same way, if 1 gram atom of magnesium weighs 24 grams, then 2.5 gram atoms of magnesium will be 25 into 24. 2.5 into 24. How much is the value?
Sir, 60 gram.
gram,
It is coming out to be
60 gram.
60 grams. Okay. Now in the next question, it's just the reverse. You are given the mass of nitrogen and you have to calculate how many gram atoms of nitrogen are present in it. What's the relation between number of gram atoms and nitrogen? Nitrogen's atomic mass is how much?
Sir,
14.
Sir,
14.
14.
14.
So it's not U, beta. It's 14 grams, isn't it?
Yes,
So
sir,
14
sorry.
grams, 14 grams of nitrogen is equivalent to 1 gram atom of nitrogen or not? Yes or no?
Yes, sir.
So if 14 gram of nitrogen is same as that of 1 gram atom of nitrogen, so come to the question, 1.4 grams of nitrogen will be how much? Unitary method, it will be 1 by 14 multiplied with 1.4 gram atom of nitrogen. So that comes out to be 0.1 gram atom of nitrogen. Anyone having any doubt? Please clear it up.
Sir,
Yes.
sir, in this second question, sir, if we don't write in terms of grams, so can we also write 14 gram of nitrogen consists Avogadro's number of atoms?
But in the question, what you are asked to calculate is number of gram atoms. If it would have been asked calculate the number of atoms in 1.4 gram of nitrogen, then I would have used that Avogadro's number of atoms.
Oh, okay, sir.
You are asked to calculate number of gram atoms, isn't it?
Yes, sir.
So gram atom is 1 if mass of nitrogen is 14 grams. Clear?
Yes, sir.
And what you are saying, I would have done that if the question would have been calculate the number of atoms in 1.4 grams of nitrogen.
Yes, sir.
Yeah.
Yes, sir.
Okay. Yes, any other doubts? Please clear it out. It's better. It's always good you clear out your doubts without any confusion. The 1 gram atom contains how many atoms in it?
Sir, 6.022 into 10 to the power 23.
Atoms. And 1 gram atom weighs equal to how many grams? One gram atom weighs equal to how many grams? It's not a specific value. It differs from atom to atom. But if it is asked that 1 gram atom weighs equal to how many grams, what will be your answer? It will be gram atomic mass.
Gram
Isn't it?
atomic mass.
Yes. So just as 1 gram molecule has how many molecules in it?
Sir, Avogadro's number of molecules.
Yes. And if I ask you, what is the mass of 1 gram molecule of any substance?
Sir, gram molecular mass.
Gram molecular mass. Clear?
Yes, sir.
So just as we did it for atom, now you try it out yourself for molecule. How many gram molecules are present in 4.9 grams of H2SO4? Question number B. Calculate the mass of 0.72 gram molecules of carbon dioxide. Try this out. Take your time, think about it. There is no hurry. The thing is, you must understand it properly. That's what you are doing. I'm waiting for someone to give you the first answer. Give me the first answer. Let me see.
Sir, is it 0.05?
Yes, exactly. It is 0.05. Good girl. So at the very outset, when we are to find out the gram molecules and mass is given, so we are going to calculate the gram molecular mass of H2SO4. So we need not calculate it again because we have already discussed today itself that it is 98 grams, isn't it? So if gram molecular mass of H2SO4 is 98 grams, then how many gram molecules are present in 98 grams of H2SO4?
Sir, 1
Is it
gram.
not 1 gram molecule? 1 gram, not 1 gram molecule, isn't it? 98 grams of H2SO4 is same as that of 1 gram molecule of H2SO4. Now come to the question. If 98 grams of H2SO4 is 1 gram molecule of H2SO4, so therefore 4.9 grams of H2SO4 will be 1 divided by 98 multiplied with 4.9 gram molecules of H2SO4. One by 20 is 0.05 gram molecules of H2SO4. Any doubts? Please tell me. কারোবার কিবা ডাউট আছে যদি? Aniket, is it clear?
Yes, sir.
Anesha?
Yes, sir.
Tamanna, is it understood?
Yes, sir.
Okay. So likewise, you try to calculate the second one. What is the gram molecular mass of CO2? You first calculate.
Sir, 44 gram.
4 gram.
Gram molecular mass.
Sir, my answer is coming out to be 0.01 gram.
0.01. Okay, let me see. So gram molecular mass of,
Sir,
yes, beta.
sir, I got 31.68 gram.
Okay, so both of you are getting different answers. So of course, any one of the answer will be correct. That is what we are going to find out. So gram molecular mass of CO2 is 44 grams. You need to calculate the mass of CO2. How much mass of CO2? 0.72 gram molecules. So since gram molecular mass of CO2 is 44 grams, so can we write 1 gram molecule of CO2 will weigh 44 grams? Can we write it? Now come to the question. How many gram molecules have been asked? So will it not be 44 into 0.72 grams?
33.68.
Check it out once again. 44 into 0.72 is how much?
33.68 gram.
Sir, 31.68 gram.
Sir, 31.68.
Do the multiplication properly. 44 into 72. (3168). Now prior to 72, so it will be 31.68, isn't it? Okay, someone was saying 0.01. Where did you do the mistake?
Sir, yes, I was mistaken. Sir, actually, I thought it was some separate kind of question.
Okay. Have you understood?
Yes, sir.
Okay. Next question. Which one of the following has maximum mass? Zero 0.25 gram molecule of H2O, 2.5 gram molecules of SO3, 1 gram molecule of O2, 0.05 gram molecules of sugar. So all of them are gram molecules, and you are asked that which one of them contains maximum mass, which means all of them have to be converted to grams. How can you convert gram molecules to grams? Yes, can anybody tell me how can you convert gram molecules to grams? By multiplying with what? Swastika,
Sir,
any idea? How can you convert gram molecules to grams? All of them need to be converted to grams because then only we can compare their masses, isn't it?
Sir,
Yes,
by
sir.
multiplying Avogadro's number.
No, nowhere Avogadro's number is required
Sir, with gram
because
Molecular
molecular
mass.
mass. Sir, gram
Hmm.
molecular mass.
yes, you have to multiply all the values with their respective gram molecular masses. Because if you multiply all of them with Avogadro's number, you will get number of molecules, not masses. So you need to convert them to masses. For that, you have to multiply all the values with the respective gram molecular masses. Suppose water. What is the mass of 0.25 gram molecule of water? It will be 0.25 into 18 grams, isn't it?
Yes, sir.
So likewise, you convert every one of them to their respective masses. See, you have to be very much clear. Still, some of you have confusion regarding when should I multiply with Avogadro's number and when should I multiply with gram molecular mass. If you are to calculate the mass, you have to multiply with gram molecular mass. And if you have to calculate the number of particles, then only you have to multiply with Avogadro's number. So individually calculate the masses of each and every one. What is the first one coming out? How many grams?
4.5 gram.
4.5 grams. Okay, fine. What about the second one? How much is the gram molecular mass of sulfur trioxide? Sulfur is 32. Each oxygen is 16. 48. 48
80
plus 32 is how much?
80 gram.
80. So 2.5 into 80 will come out to be how much?
Sir,
200.
200.
Sir, 200.
The answer to the second one will be 200 grams. Third one, it's simple,
32.
32 grams. because gram molecular mass of O2 is 32 grams. There are 2 oxygen, and since 1 gram molecule is asked, so directly you can write 32 grams. And what you are supposed to multiply with 0.05 to get the mass of sugar?
Sir, 342.
342. So how much will it come out?
17.1.
Sir, 17.1.
Okay. So when you compare, which do you think has got the highest mass? Is it not option number B?
Yes, sir.
This is 4.5 grams. This is 200 grams. This is 32 grams. And what you said about the last one?
Sir, 17.1 gram.
So of course 200 gram comes out to be the highest. Clear?
Yes, sir.
Everyone is understood?
Yes,
Any
sir.
doubt?
Yes, sir.
Okay, fine. Now, before going to the next type of question, I need to explain it first so that everyone is clear about it. Suppose we have got a large molecule C12H22O11. It comprises of 3 different type of atoms. So if I write 1 gram molecule of sugar, okay, if I write 1 gram molecule of sugar and I want to convert them to their individual atoms, so can we write contains 12 gram atoms of carbon? Yes or no?
Yes, sir.
Yes, sir.
How many gram atoms of hydrogen will be present?
Sir, 22.
22 gram atoms of hydrogen. And how many gram atoms of oxygen will be present?
Sir, 11.
11. Now, 12 gram atoms of carbon can be written as 12 into 12 grams or not? Each gram atom of carbon is 12 grams, isn't it?
Yes, sir.
Yes, sir.
So 12 gram atoms will be 12 into 12. That comes out to be 144 gram of carbon. See, I have converted first molecule to individual atoms and then individual atoms to mass. Likewise, what should I write here?
Sir, 22 into 22 gram.
20 into 1.
Why did you say 22 into 22? Previously, number of atoms were 12 and atomic mass of carbon is also 12.
Oh,
Now
yes,
here,
sir.
is the atomic mass of hydrogen 22 or 1?
Sir, 1.
1. Likewise, what should I write here?
Sir, 11 into
11 into
16.
16. 16.
So 11 into 16, कितना होगा देख लो?
Sir, 176.
176.
यहाँ तक सबको समझ आया कि नहीं? देखो. How we can break up the molecule into individual atoms. Yes or no?
Yes, sir.
Yes, sir.
When you add up these values, will it not come out to be 342?
Yes, sir.
Yes, sir.
Okay. And that 342 gram Is 1 gram molecule of sugar or not?
Yes, sir.
Yes, sir.
The only difference is we have written in separate form. I'm not saying this is equal to this. I'm saying this contains this much of carbon, this contains this much of hydrogen, this contains this much of oxygen. When you add all of them, then only everything will be equal to this. Clear?
Yes, sir.
Write down a question. Calculate the mass of carbon in 0.5 gram molecule of K4 FeCN whole 6. You have to apply the same kind of idea to get the answer. Think about it. Calculate the mass of carbon in 0.5 gram molecules of K4 FeCN whole 6. So how many grams of carbon are present in 0.5 gram molecule of K4 FeCN whole 6? So of course, we cannot jump directly to 0.5 gram molecule of K4 FeCN whole 6. You have to go to the natural relation. 1 gram molecule of K4 FeCN whole 6 contains how many gram atoms of carbon?
6 grams.
6. So if 1 gram molecule of K4 FeCN whole 6 contains 6 gram atoms of carbon, then 0.5 gram molecule will contain how many gram atoms of carbon?
6 gram atoms of carbon divided by 0.5.
Will it be divided by or will it be multiplied with?
Sir, multiply.
So
Yeah.
multiply.
It is to be multiplied. Because after 1, whatever number you are including, it is to be multiplied. To get 1, you have to divide. Okay, so how much is 6 into 0.5?
3.
Is it not 3 gram atoms? So 3 gram atoms of carbon weighs how much? Because ultimately we need to calculate the mass of carbon.
36 grams.
36 grams.
36.
So 36 grams will be the answer. .5 gram molecule of K4 FeCN whole 6 contains, it is not equal to, it is a symbol for contains, 6 into 0.5 gram atoms of carbon. If instead of carbon, it would have been asked in terms of potassium, then I would have written 4 into 0.5. Had it been iron, I would have written 1 into 0.5. Had it been nitrogen, I would have written 6 only. So this is equal to 3 gram atoms of carbon. Now 3 gram atoms of carbon is 3 into 12 grams because gram atomic mass of carbon is 12. So is it not 36 grams of carbon? See? Yes or no?
Yes,
Yes,
sir.
sir.
I hope it is clear to everyone.
Yes, sir.
Okay. which one of the following contains maximum mass of carbon? Option number A, 0.25 gram molecules of glucose. Option number B, 0.5 gram molecules of benzene. Option number C, 0.25 gram molecules of sugar. Option number D, 5 gram molecules of methane. So everyone has carbon in common. So same method you apply here to get the mass of carbon only. Compare it and then tell me which do you think has got maximum mass. Write out. See how many of you can do it. Now coming to option number 1, 1 gram molecule of glucose contains how many gram atoms of carbon?
6.
6 gram atoms. So accordingly 0.25 gram molecules of glucose will contain how many gram atoms of carbon?
Sir, 6 into 0.25.
And that has to be further multiplied with 12 or not?
Yes, sir.
Yes, sir.
So that way you calculate for each and every individual. So directly we can write it 6 into 0.25 into 12. Likewise, what can we write here? Tell me. How many carbon atoms are there?
6.
6, na?
6.
So 6 into 0.5 into 12 होगा ना? Next to क्या होगा?
Sir, 12 into 0.25 into
12.
And what about the last one?
Sir, 1 into 5 into 12.
Very good. Now you compare the values. See, 12 is common in everyone, isn't it? So you can simply multiply these two values because as such 12 is common. So if you compare these values, the one with highest value ultimately will be the maximum mass because as such 12 is multiplied with everyone. No need of multiplying with 12 as it will take longer period of time. So how much is 6 into 0.25? 0.25 I think is 1/4, isn't it? Is it not 1.5?
Yes, sir.
Yes, sir.
Yes, sir.
0.5 is 1/2. So will it not be 3?
Yes, sir.
and 12 into 0.25, 1/4 of 12. This is also 3. And this, of course, is 5. So which do you think is the highest value?
Sir, D.
D.
D. Understood? So when you sit for entrance exam questions, these are the type of questions that will be asked. So you have to be accurate, plus you have to be fast. You need to do smart calculation because it's a question on comparison. So don't waste time in complete calculation, because by that time you can do another question. Otherwise, you will be running short of time, as time given is limited. Have you understood the logic I have used here? Why we did
Yes.
not multiply 12 with everyone?
Yes, sir.
Yes, sir.
But if the atoms would have been different, in one option carbon is to be calculated, in another option nitrogen is to be calculated, there we don't have any option, because atoms different means their gram atomic masses will be different. So there you have to do the complete calculation. Understood, everyone? Bachcho? Clear?
Yes, sir.
Do one more. Calculate the mass of sulfur in 0.5 gram molecules of H2S2O7. Let me see who can do it very quickly as well as correct.
Sir, 32.
Bah, how could you do it so fast?
Sir, 32.
Okay.
Sir, 32.
So 0.5 gram molecules of H2S2O7 is equal to 0.5 into 2, because there are 2 sulfur. And what is the mass of each sulfur? Is it not 32 grams? Okay.
Yes, sir.
So simply you have to remember that what are the values that needs to be taken out, needs to be used. So I must write this equivalent of sulfur. They are not equal. Anyone so far having any doubt? Because on the basis of 2 to 3 answers I'm getting, I'm going fast, assuming that others are also understanding. Tamanna, are you understanding, bacha?
Yes, sir.
Okay. Swastika, comfortable?
Sir, yes.
Okay. What about the newcomers? Tanisha,
Yes, sir.
clear? Tuhina?
Yes, sir.
Okay. All of you sound very similar. I cannot make out who is who. Which one of the following has maximum and minimum mass. (25.6 gram of oxygen, 2.56 gram atom of sodium, 0.256 gram molecule of water, 0.256 gram molecule of iodine. Did I give you the atomic mass for iodine in last class?
Yes, sir.
How much? It gram atom kore diya. Last one is gram atom. How much is the value of iodine?
Sir,
1.
125.
So
127. Water 18 grams, sodium 23, oxygen 16. Okay, so the moment I give you the atomic masses, which I am not supposed to give you because that you have to memorize, the question becomes very simple. First one, it is already given in mass, isn't it?
Yes,
Is it not
sir.
mass? So don't make any change. It is same, 25.6 grams only. But rest, all of them have to be converted to mass because they are not grams, they are gram atom, gram molecule, gram atom. If it is gram atom, in order to convert into grams, it is to be multiplied with gram atomic mass. If it is gram molecule, it is to be multiplied with gram molecular mass. So the answer of the second one will be 2.56 multiplied with 23 grams. Answer to the third one, 0.256 into 18 grams, 0.256 into 127 grams. See, if instead of gram atom of iodine, the question would have been gram molecule of iodine, then what I would have done? What is the formula for iodine molecule? Can you tell me what is the formula for iodine molecule? How is iodine molecule represented as? Is it iodine molecule or iodine atom? Is it iodine molecule or iodine atom?
Atom.
Iodine atom.
Atom. But if I would have written I2, then it would have been molecule, okay? If the question would have been gram molecule of iodine, so what I would have multiplied this value with?
2.
254, isn't it? Not 2, 254. It would have been doubled up because each iodine is 127. So had it been I2, then it would be multiplied with 254, which is double to that of 127. Clear? Now you compare and tell me which is the minimum mass, which is the maximum mass.
Sir, iodine atom has the maximum mass and water molecule the least.
Maximum mass, how much you are saying?
325.12 gram.
Sir,
This one?
maximum is sodium or what? Sodium?
Sodium is maximum. And which is the minimum?
Sir, water?
See whether everyone is getting the same answer or not.
Yes, sir.
Because don't go by the value of atomic mass of iodine. It may be very large, but it is multiplied with a very small number, isn't it? 0.256 is a very small number. So ultimately, upon multiplication, I don't think iodine is maximum. Yes or no? Minimum is water. Everyone getting?
Yes, sir.
Yes, sir.
And maximum will be sodium. Because the things will be clear only when we multiply the values. So for iodine, what is the value coming out?
Sir, 32.512.
32.512. Okay. And for sodium,
Sir, 58.88.
58.8. So of course it is larger. And if you are asked to arrange them in increasing order, which do you think has got the minimum? Of course, water will come first, followed by
Oxygen.
followed by oxygen, followed by iodine, isn't it?
Iodine. Yes, sir.
Followed by sodium. Clear? Understood? Should I move on?
Yes,
Yes,
sir.
sir.
Yes, sir.
Calculate the mass of the following. Zero 0.25 gram atom of oxygen, 0.1 gram molecule of oxygen, 0.25 gram atom of nitrogen, 0.01 gram molecule of nitrogen. What is the formula for atom of oxygen? How do we represent atom of oxygen?
O.
O. And what is the formula for molecule of oxygen?
O2.
Sir,
O2.
O2. What is the formula for atom of nitrogen?
N.
sorry,
N. And what is the formula for molecule of nitrogen?
N2.
N2.
So that has to be kept in mind. So here, this 0.25 is to be multiplied with what value?
Sir,
If O is
16.
the formula, 16.
Sir, 16.
And here 0.1 is to be multiplied with what value? Will it be 16 or something else?
Sir,
32.
32.
Sir, 32.
Yes, because molecule of oxygen is O2. So likewise, it is 0.25 into 14 or not?
Yes, sir.
But here it will be 0.01 into 28 or not?
Yes,
Yes,
sir.
Yes, sir.
So keep that in mind. If it is atom, it will be represented as O, N, etc. If it is molecule, O2, N2, etc. So compare the values and tell me what's the answer coming out. I think the first one is 4 gram.
Yes, sir.
Second one, 3.2 grams.
Yes, sir.
Third one, 1/4 of 14. 4 3s are 12. 23.5 gram, Nikki.
Yes, sir. Yes, sir.
Yes, sir.
And this one 0.28 grams, isn't it?
Yes, sir.
Yes.
So this is what I was explaining, that in the previous question, instead of gram atom of iodine, if it would have been gram molecule of iodine, then I should not multiply with 127. What should I multiply this with?
256.
254. If it would have been
254.
gram molecule, which means iodine is not present in atomic form. Iodine is present in molecular form. And in molecular form, what is the formula? I2, isn't it?
Yes,
Just
sir.
like it was N2, this was O2. So the moment I write it as I2, so will it be 127 or 254? It will be 254. Understood? So be very clear. What are the terms written here? Are they atoms written or molecules written? If they are atoms written, so we will have to use gram atomic mass. And if they are molecules written, we will have to use gram molecular mass. Yes, children?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So please go through the questions that we have discussed today. Once again, go through them, and still if you have got any doubt, you can clear it out. So next day we will discuss a very, very important part of this chapter, that is mole concept. So everyone has to be present. It is must. Otherwise, you will face problem in these 2 years, as mole is one of the basic platforms, or you can say structure, to understand the physical chemistry. Thank you. Good night, all of you. Take care.
Thank you,
Thank you,
sir.
sir.
Thank
Thank you,
you,
sir.
Thank you, sir.
Okay.